Okay, we're going to look at section 3.2 for this one, and this is now going to be measures of spread. So in the last section, we talked about measures of center, kind of a centralized middle style value for a data set. Now we're going to talk about how spread out the data set is. So the first and probably easiest one of these to do is the range. And the range is just the difference between the largest and the smallest value. So you're going to just subtract those two values, okay? So for example, we've got this one with degrees Fahrenheit. The highest value is 63 in September. The lowest value is 51 in January. So if we subtract those, we get 12, okay? Now, although this is really easy to compute, it's not often used a whole lot because you're only using two values, okay? And if you have like an extremely large or extremely small value, that can oftentimes throw this off. Now, the reason that we want to look at measures of spread is because we can have two data sets that have the same mean and median. They can even have the same mode, but it doesn't mean that the data sets are similar in their makeup. So for example, I could have two statistics classes and both of them on a test have a mean or an average grade of 70, a median grade of 72, and they don't have a mode. However, one of my data sets may only have scores that are between 60 and 80. The other one may have scores that are between 40 and 100. So in one class, it's kind of one of those, well, if I failed it, I didn't fail it by much, but we also don't have anybody knocking the top off of it. And, they basically, top grade was just a B. The other one is we've got top grades of A's, and even somebody did really well, maybe made 100 on it, but we've got people that were not passing it well at all and making like a 40. So, but the concern is that those would have the same mean and median. Range would certainly be different for that one. And that's why we need to know what the spread is, because that helps us get an idea of, is my data set really tightly packed together, compact, or is it more spread out and open, okay? So now, one of the other things that we look at here is what's called the variance, okay? And the variance is how far out the values are from the mean. So when we talk about variance, and again, we'll go with this idea of the test scores. If the mean is 70, then a test score of 75 has a variance of 5, okay? Because it's 5 above. So the positive indicates that the actual test score, 75, was above the mean. Now, if I have a grade at 67, it would have a score that was -3, okay? Because the negative would indicate that it is under. And so one of the things that we have a concern with here is that if we were to add up, say, the +5 and the -3 and whatever else, it's going to balance out to 0, because the whole idea of the mean is that those higher values and those lower values balance each other out. And so the question is, well, how do I deal with that? Well, we've got a couple options. One is we can certainly do absolute value. Absolute value is going to turn everything positive. That's great and it's wonderful. Problem is it's kind of hard to calculate with that because you have to kind of really put your hands on every single value. The other option that we have is we can square stuff. And so when you square things, certainly positive things squared are still positive. When you square a negative number, it also turns positive, okay? Now, one of the things that we do have to worry with is when we're working with population versus sample, they are slightly different in the formulas. And that's because in the population, we have every single value, but in a sample, we don't have all of the values. So on the sample one, we've got to give ourselves kind of a little more wiggle room when we're processing through that. So now, the PowerPoint is going to present one formula for this, and it's a pretty formula. It's nice. It looks very simplistic. I'm going to show you an alternate formula for it that's actually a bit easier to compute by hand with this one. And I'm going to show it for both population and variant, population and sample for our variance stuff. And then we will also, I'm going to show you how to compute one of these by hand. We're also going to talk about how to put this on a calculator. So notice with this one, what it says we're going to do is we're going to take xi, which is just our value. We're going to subtract the mean, and then we're going to square that, okay? And we're going to do that for every single data point, and then we're going to total that up, and we're going to divide by n, okay? So now the notation, again, in population here, we see those Greek letters show up. This little O with the little tail across the top is sigma. It's actually the lowercase version of sigma. So variance is sigma squared. It's always going to have that squared on it if we're talking about the population variance, okay? Now, for the sample, okay, very, very similar. The change out here is we do use S for this one, and we use X bar. And so the way that we do this one, the only big difference is we have the N minus 1 on that bottom part. So we see that happen, and that is how we make that adjustment, is because we're dividing by something that is slightly smaller, which means the outcome is going to be slightly larger. Okay, so I'm getting these formulas written up on our other thing, and we are fixing to work through one of these. And again, we're going to talk about how to get through it on a calculator as well. So again, with this N minus 1 thing for the sample variance, the reason that we do this is we don't have all of the values, okay? And again, because we don't have all the values, we got to allow ourselves this kind of error correction for it so that we are closer to accurate with it, because we don't want to kind of underestimate or underguess what's going on here, okay? Now then, along with variance, we have what's called the standard deviation. And the standard deviation is one that's actually calculated more often than the variance. Now, for the sample standard deviation or for the population standard deviation, it is simply the square root. So it's either plain S or plain sigma. Now, it's important to note here that oftentimes we have that, especially with the calculator, we're going to have a standard deviation calculation that's given to us, which means if they want the variance, we're going to have to take that standard deviation and square it, okay? Because they're going to give me S, and then remember that the variance was the squared version of that, okay? So kind of a slight bit of work backwards there as we're processing through there. So let's take a look at one of our lovely example problems. We're going to take a look at number 1 here in our worksheet, okay? So this is what I was talking about with the formula. So for population, which is the sigma squared one, okay, we're actually going to take the x's and square them and then total that up. This is, we're going to total up just the plain x's by themselves, and we're going to square that total. We're going to divide by n, which is the number of data points. We're going to do that math up there and then divide by n once again. Over here for sample variance, which is s squared. Okay, we're going to have same setup. Again, the only difference here is we have this n minus 1 down here on the bottom. Okay, so for this lovely problem that we have, I'm going to write my set of numbers down. Okay, so these are my x's. Now, I'm really only going to need 2 columns to be able to do all of this math. So looking through my formula, I'm going to need an x squared column. Okay, so I'm going to do 16 squared, which is 256, 34 squared, which is 1156, 24 squared, which is 576, 20 squared, which is 400, 12 squared, which is 144, and 36 squared, which is 1296. Okay, now I am going to need the total of this in either formula. And this particular one does ask us for sample. Okay, so we're working with our sample set here. So now we're going to total this up. So I need the total of my x squared. And when we add all of this up, we get 3828. And then we're also going to need the total of just the x's, okay? And so when we total up all these x's, we get 142. So now, processing through this sample formula, okay? Oh, let me mark this down. 1, 2, 3, 4, 5, 6. So n is 6. Okay. So again, I'm going to work with this formula. So it wants the total of the x squared, which is 3828, minus the total of just my x's, which is 142, squared over 6 minus 1. Okay. So doing just a little bit here, I've got 3828 minus, when I do 142 squared, I get 20,164 divide by 6. I am going to go ahead and make that over 5 down here. I'm going to do this division by 6. Over 5. Doing that subtraction, I get 467.333 repeating divided by 5. And when we do that, we're going to get 93.46 repeating, which we would probably go ahead and send to 93. Excuse me. Put that here. 93.47, or they may let it go to 93.5. Okay. Now again, this was S squared. This was our variance. Okay, so this is variance. If I want the standard deviation, I'm going to take the square root of that 93.46 repeating, and I'm going to get 9.668. Okay, when it's rounded to 3 decimal places. So that's our standard deviation, and that would be just the letter S for that one. And again, that's because this is a sample for this one. Okay, now let's take a look at number 2. And first off, on number 2, I am going to do this as a population for this one. Okay, I know it says sample, but I want to go ahead and run this as a population. And I'm going to show you how to do this one on a calculator. Okay, so I'm going to show you how to do this one with a calculator. So now the good news is that a lot of this is going to come out of the same locations that we've already had. So I'm going to bring my lovely calculator over here into view. Try and get that lovely glare spot out. Okay, so we're going to start this process by hitting Stat and Enter. Okay, and we're going to clear our data list. And I'm going to go ahead and clear both of them. So again, we go up and highlight and then pressing Clear and Enter. And now I'm going to put this data set in. So I've got 18, 6, 18, 12, and 24. So I'll bring that into play here. Here's my lovely data set. Okay, we are going to hit Stat. We're going to go over to Count, and we are still picking that 1 bar stats. Now, if you still have yours set up, I still have my L1 and L2. I need to clear that L2 list because I do not have a data set in L2. And then I'm going to hit Calculate. Okay, now what you need to look at here, okay, number 1 is they give me the mean. They also give me the total of my x's, which is 78, and the total of my x squareds, which is 1404. So I can then use that to calculate in my formula. However, they also give us SX. SX is your sample standard deviation. And then they also give you sigma, or it may look like OX. In this case, that is 6.1188. That is your population standard deviation. And again, it'll tell me N is 5 and so on and so forth down the list. So for number 2, the standard deviation, okay, for this one, and we are using sigma because I said we're going to do population with this, is going to be that 6.1188 value, which means our variance, which notationally is sigma squared, is going to be that 6.1188 squared. Okay. Now, 6.1188. And so for that, I get 37.44 when that goes. Okay. I've got kind of several spots that would round on that one. Okay. So we get this as our answer value for that one. So you can use a calculator to help you find your standard deviation and your variances. Okay. With the calculator, you're probably going to be finding standard deviation first. And then variance second. If you're doing it by hand, you're going to be finding your variance first and then taking a square root to get your standard deviation.